Hey learners, Jared here, and previously we had looked at the kind of overview of an object that was moving in a circle, that is uniform circular motion. And today what I'm going to do is kind of walk you through a problem where you actually can do some calculations to figure out what is going on with that object that's going in that circle. So let's take a look at this example here. We've got a 1 kilogram object that's moving in a circle with uniform velocity. That is, its speed, it's never changing. Now the direction of the object's motion is, but its speed we're going to say is constant. Now, in order for an object to be moving in a circle, recall that there has to be a force pulling in towards that center. That is a centripetal force on that object. And let's say in this case, it's a tension force. That is a force being delivered by a string. And we want to know how much tension is in that string. Anytime we're trying to figure out a force, odds are we're going to look at Newton's second law. That is, force equals mass times acceleration. Now, if you recall, an object moving in a circle is accelerating even though its speed isn't changing, because what is changing? Its direction. So we need to know the acceleration in order to figure out the force. Well, how do we figure out an acceleration for an object whose speed isn't changing? Well, for an object going in a circle, we can look at two things. How fast is it going? Its tangential velocity, and then its radius, or how far it is from that center point. If we know both of those things, we can figure out acceleration, and if we can figure out acceleration, we can figure out force. The centripetal acceleration of an object is equal to that tangential velocity that we were talking about squared, all of that divided by the radius of the circle. Those two components affect the acceleration of an object. Now, let's say we don't know the velocity of the object. Well, we would need to know some things in order to figure that out. For instance, if we just knew the radius of the circle and we knew the time it took to go around in that full circle, well, we could use that to figure out the velocity. Remember, its speed isn't changing. And when that happens, your velocity is just how far did you go divided by how much time it took you to go that far. How far it goes in that circular path is just the circumference of the circle. If we take the circumference of that circle, 2 pi times your radius, and you divide that by the time it took to make a full revolution, that will tell you the velocity, the tangential velocity of that object for that circular path. Plugging all of that in for velocity and then squaring everything in there, that 2 pi r over t, everything in there gets squared. And then all of that divided by the radius, if we simplify that down, we can get another formula, another relationship between centripetal acceleration and radius of the circle and the time it takes to go that full revolution, to go that full circle. Having all of that information at our disposal, we can use that to calculate how much force it's going to take to get the object to actually go in the circle. How many newtons of force, how much tension there would be for that particular object at that particular circle going that particular speed. Now, when starting these types of problems, it's paramount that you know what you are looking for and what you are trying to find. Using that can lead you down those series of equations and concepts to figure out, okay, what am I given, what am I trying to find, and how do I connect those two things? Every time you run into well, I don't have that, okay, well, where does that come from? For instance, if we didn't have velocity, well, how do we figure out velocity? What is velocity? And that can help narrow your search until you're using components of the problem that you are given to connect to the unknown that you're trying to find. So hopefully that helps get you started on these uniform circular motion type problems. Again, these are different from objects that are rotating. This is still an object that is actually traversing space going in a circular path. We'll look into rotating objects next time, and as always, keep learning.